So I am Ryan Meek. I'm a product manager here. When I started, I was actually a developer. And in the beginning, we announced an HTTP REST API. And we proudly documented the core operations and described how to work with them in the application developer's guide. What this provided was, puts and gets and deletes and infos, which was actually very high throughput, very performant, and allowed our initial set of customers to get off the ground and write some pretty cool integrations. Really quickly, though, what we started hearing was, well, can you give us some examples of how you would write this? And so I actually started writing the original samples in Java and .NET. And so what that developed into was a software development kit. My samples were good, but what people were really interested in was a stable API that would make their applications forward compatible. So we followed that with Java, .NET, Python, C++, and we also wrapped it in what we had been advising as best practices for writing native applications. And this is really where you get into high throughput and high performant applications. In particular, we added facilities for things like connection pooling and keep alive sockets. So, when people are writing high performance applications, especially when they're on-prem and they want high bandwidth and high throughput, you want to do the things in HTTP that we first came out of the gate saying, hey, it's easy, just use your HTTP library, every language will have them. And then we quickly found out people could benefit from a professionally developed SDK. So that's what we've had since. It's been very successful. It's been very forwards compatible because people need to know when they write an application, it will work with your future generations of product. One of the other things that it actually implements and supplies that everyone is interested in is a locator strategy. So when applications pop up, these are HTTP endpoints. So you have IP addresses, essentially. And so the issue is, okay, well, where do I find my nodes and how do I find my clusters? So that actually ends up being a nice little bundle of best practices code that allows people to either seed their cluster groups with names, use DNS, or static groups of IP addresses. So the clusters are really high available by nature, but you want applications that are written with best practice facilities to really make sure that those applications have high performance and high availability access to the clusters. Is there any questions about that as we go? I know we're moving pretty quickly here.
I actually have one question. I noticed you were using Google Drive. Mm-hmm. Do you have your own Dropbox? I would assume you do, but I just saw the Google Drive and made me think.
We actually do, and I believe that's going to be a good teaser to what's going to come up next, because we'll take you through it. And so actually I've been really lucky. I've been able to work with quite a few of our customer implementations, and both that use the SDK for their own products in their own house, like corporate IT and their own custom applications, but also groups that are doing partner integrations like Semantic Enterprise Vault or Veritas now, Enterprise Vault, Commvault. Applications like this have written to us directly and they've taken advantage of our compliance features. And they've been very forwards compatible, so that's been very successful. People are also building OEM services using our technology. So telecoms are the biggest example of that, but it also includes people like Data Deposit Box that Tony mentioned that provide the online backup services if you buy a Dell laptop, for instance, or say NetMail, for instance, a partner that does email archive back to on-site clusters. So these are all, it's HTTP, so that's stable, and it's open, so it's open access to all the data. And overall, it's to provide a very reliable and forwards compatible integration layer.
Are you seeing anybody do maybe SQL backups or anything to this? I mean, is there a benefit to it? Anybody doing it?
SQL backups in the sense of database backups?
Yeah, like a database backup.
Yeah,
Is there
that's-
any-
File backups in
File
general.
backups in general, right?
Yeah.
Yeah, so I
Or
mean
like
that
a Veeam repository, or,
So-
backup repository. You said Commvault, but
Yeah, so Commvault is one that does it directly. Data Deposit Box does backups from laptops to it directly. Corporate IT shops have, backed up they've done their MySQL dumps and then, put it on a cron job to push them all to the cluster. I mean, that is a really easy thing to do. EV from Veritas, that's right. Yeah, that's absolutely something that people jump straight into, especially from the corporate IT side.
yeah. Okay.
Yeah. So we've also added Hadoop integration by implementing the FS interface from Hadoop. So you can use the Hadoop command line tools to copy data to and from Swarm. It also means that Hadoop jobs can run MapReduce jobs on data that's in Swarm. And this is applying to the rest of the projects in the Hadoop infrastructure like Spark that are coming along as well. So why would you want to do that, right? You've got a big HDFS cluster, it's piling up with data. The biggest reason is that's generally or always 3 replicas. And so if you have 1 or 2 petabytes, that becomes 3 or 6 petabytes. Those additional petabytes really hurt. So Swarm's an outstanding place for a very efficient storage footprint. If you made that 10-2 erasure coding, so 10 data segments and 2 parity segments, that's a 20% overhead instead of a 200% overhead for data protection.
But what about the performance then?
I'm sorry?
The performance.
What about performance? Because erasure coding.
So what we see is people don't want to replace their HDFS clusters. They like their HDFS clusters. They work exactly the way they need to work for Hadoop. And so in a lot of cases, we've also seen that grow up kind of outside of the corporate IT compliance department, where it's a little bit of a Wild West and data analysts are off doing their own thing outside of DR situations, for instance. So we mostly just say, keep the data in HDFS as long as you want to, but you can push it to Swarm, maybe once it's colder, maybe once you've run your monthly reports, but you want to keep all the data. People want to keep all the data all the time now. So this is an efficient place to do it. Hadoop's also a batch-oriented system in a lot of cases, so it's ideal for the power management and the power savings. And then once it gets pushed to Swarm, it's also hooked up with usually a disaster recovery cluster in another place. So then, the corporate IT compliance guys are happy because now the data is actually, protected at multiple sites as well. So we don't try to make the claim that it's just as performant as HDFS. I mean, HDFS is really the perfect place to do things that people are building around. Yes.
However, if you need 3 reps and you need performance, we can give you that. There's no.
We can.
It depends on the
But
deployment.
generally, we don't try to talk people out of using HDFS. It's great for what it is.
But you can, but then you need to do replicas instead of erasure coding probably.
It would depend on the access pattern, certainly. If you're reading whole files, whole objects, it depends how parallel that is. Do you have processes that are all reading their own little segment part of it? Well, we officially support range reads, and so it may be the case that you're hitting different segments of the file. So I can't just say it's one way or the other for you. It's going to be very use
It will
case
generally perform. I mean, people that are doing a lot of HDFS and Hadoop and paying attention to performance, they'll want to keep it on HDFS. That's exactly what it grew up doing.
So let me understand. Do you have like a archive layer for HDFS and Hadoop, or are you actually an active HDFS supporter and supplier? So if I wanted to run an HDFS cluster with replicas under Caringo Swarm,
Right.
I could certainly do that.
Right.
Without any
So the
problem.
answer is both, I believe. So in the most common case, what we see is people will move the data to Swarm after it's cold, or after
they've done their
using
analytics on it
That's
and
right.
such.
Now that being said, they can still access it and they can still run analytics on it, especially they take advantage of streaming it back and, counting, doing counts, doing reports, that it might, it would work just fine. So it's really accurate in both cases.
Are you seeing similar things like with Elasticsearch, things like that, using this as an Elasticsearch, like archival?
Yeah, exactly. So you could also use it in exactly
Like if I'm doing logging or something
Yeah,
like that, and I want to
absolutely.
have, archive data that's still accessible through my Elasticsearch.
Yes, absolutely.
HDFS has recently added erasure coding, has it not?
So they've checked it in,
Yeah.
But most people aren't using it yet.
Okay.
And you're still paying support on additional clusters, and the erasure coding is not as flexible as ours is, for sure. I mean, I don't think it would be out of the box with the codes. And so, in a lot of cases, this is as efficient and, both from a footprint standpoint and from a power standpoint as it will happen. And it's also the most flexible to expand. So we see this as the most efficient way to archive that data.
Does SwarmFS support flash or SSDs anywhere in their hierarchy, or?
We work with all of them, and we have customers that, they put together special clusters especially for those use cases. And in a lot of cases, it'll be something like thumbnails, for instance, or videos that are coming up that need to be served extra quickly.
Would a whole cluster be a flash cluster versus a
People do that in some cases, yes.
But you could actually have
total
tiering
throughputs
within
are
a
ridiculous.
Swarm cluster?
Sorry?
Could you actually have tiering within a Swarm cluster so that in LifePoint's perspective, for a certain amount of time, the thumbnails would exist on flash and then move off the flash to something else?
Not specifically designated, but the data market actually makes it such that instead of sending a fixed number of operations to all the devices that are faster will consume many more operations. So we naturally get coverage through the market. It's not a specific facility.
And it's also safe to say that we can enhance the data market. The data market, over the years, we adjust the data market based upon our observations and testing. And so the data market can be adjusted for additional preferences over devices like you're asking about.
Mm-hmm. So I specifically wanted to be able to get back to Justin's question too about use cases. So I wanted to make sure he was happy before I went on. So cultural archive, we see a lot in museums, especially digital archive. It's especially important to them that they have a plan in place so that this system can incorporate new hardware. It's not reliant on the hardware. They don't have to move it in a forklift upgrade. They can add new hardware as it comes out. The new objects will naturally be migrated to the new volumes by way of the data market that Russell was explaining. And this is really a set of content that will move forward in time, even though you rotate in new hardware underneath it. It's also important that the data not be deletable in many cases. I mean, they specifically don't want the data to be deleted, and that's a real management policy that has, it's why the system is there in many cases. Digital evidence, we see this all over the world. We see it in law enforcement contexts, we see it in government contexts, we see it in military contexts. It's massive data. In many cases, it's data that needs to be on-prem. In many cases, it's not even connected to other networks, or there's, serious security measures involved. And so those are very specific things that object storage and Swarm are specifically excellent for. And content delivery in general, we see, quite a bit of scale-out video, scale-out photo, and there's a lot of overlap there with digital evidence as well. So I wanted to make sure I got specifically back to you, Justin. I was looking for a head nod there.
So from a digital evidence perspective, do you have, I'll call it audit logging of accesses to objects?
We have audit logging not only of access to objects, but all management settings changes. I mean, all new objects, everything that goes into the system. That all needs to be something that someone can go through later and review.
Yeah, so that's something I would like to understand a bit more, is some of that digital evidence, both from two perspectives. On the one hand, you've got legal and regulatory compliance things where
Right.
we want to be able to put a legal hold on certain information and so
Right.
on. And there are various tools that can do that.
Right.
It sounds like the search capability that you have is metadata based.
Right.
So we would need to have some sort of metadata tagging put onto that. It sounds like I'm going to need another tool layered on top of Caringo to make all of that happen. I'm thinking something like Veritas Enterprise Vault or the journaling systems.
So in many cases, people are actually writing their own applications as well.
Okay.
So that comes back to how they use the API.
Yep.
And how they use those features in the API.
Yep.
But in many cases, so for instance, policy-driven life cycles, those are also available because it's metadata and it's also indexed and searchable. So when people have questions about it or when they need to review it very quickly, it's there.
Yep. And then sort of following on from what I think it was Ray was talking about there, the tracking that people have actually accessed some of this is interesting to me, particularly because in Australia we've recently passed metadata collection laws. So now the government is mandating that for 2 years your internet history will be recorded by your ISP with no warrants and oversight of some description, apparently.
Shots.
Is the tracking and auditing the kind of thing that will be on permanently so that when the police go and illegally access someone's metadata, when, not if, because they will,
Yeah.
they have, is it the feature capability there that it can't be turned off by nefarious actors who are trying to cover their tracks?
Well, I mean,
can
I would
talk to
say,
I can talk to that. The audit logging output is, I can leave you with the documentation for it, but it is actually done in a way that is meant for machine parsing. It's actually routable. It's down in the technical levels, it's actually log4j compatible. So there's a lot of choices in terms of how you can direct that audit stream. You can direct it to multiple places, in fact, so that you could apply analytics to it. You could also sequester it in a way such that you are by splitting the stream for normal day-to-day stuff, but then sequestering it in a separate system for evidentiary rules that may be in place.
you could also direct
be
it
cool.
to a compliance department. I'm not sure we answered your question that we could lock it from changes. I think it's probably still available.
The ability to
an
emit the
administrator.
changes off to another recording system,
Oh, yeah.
which could then, so I'm thinking in that case, it could be for judicial oversight, for
Yes.
example. So we can see, okay, NSA, you told us that you had this many requests to access stuff, but that doesn't match with our audit information. What's going on? Please lie to me some more. So, not that I'm biased or anything.
Yeah.
So yeah, it's good to have multiple levels of that audit capability because, I mean, there are other circumstances where that could be the case as well, where you have someone who actually hacks into your systems and then looks at it. One of the things you do with a rootkit is you try to scrub out all the logs to hide the fact that you actually did break in and do anything. So having that come off to another system which is tamper-proof, or at least tamper-resistant, is a good feature for showing chain of evidence and making sure that you've got all of those ticks and
I think
boxes.
we would at least have tamper
So I
evidence.
think, I think we can address that because we do allow that stream to be split multiple times if that's necessary.
Yep. Okay.
There's a question from the audience about, can you tell us a little bit more about erasure coding, I guess in comparison to replication? What does it really do? What does it mean? That sort of thing. Maybe you can give
Okay.
a
So,
high-level overview of that.
Replication in general is almost, it's 3 additional copies or 2 additional copies of all the data of an object and all the metadata of an object. So in our case, an object is made up of metadata and data. And if you protected that data with 3 replicas, you would have 3 actual identical sets of those data. And so we would just think, although it's just a tiny bit more, we would think of that as from a usable 100%, that would be to about 300% raw capacity. So erasure coding is a different strategy where you actually slice the data, and it's almost like object level RAID. If someone's watching and has a good idea of RAID and how it uses algorithms to slice up content and then reform the content, erasure coding, you can think of it as object level RAID. And so we see a very common code as 4-2.
And what does that mean? 4 data
That
drives
means
and 2 parity drives?
4 data segments and 2 parity segments.
And you can lose up to
You lose up to 2.
2
You can
drives in that
reconstitute
6
the
drive
object
set.
with any 4 data segments. So in that case of a 4-2 code, that would be a 50% overhead for the data protection, which would roughly correspond to a RAID 5 or a RAID.
And can that be set to anything like 2017 or
In our system, it can, and it's extremely
19.1?
flexible. It's extremely flexible that way. Yes.
Yeah, that's one of the advantages of erasure coding is instead of having RAID 5 define what your not resiliency, what's the word? The durability of the data. With erasure coding, you can dial it in to have, I want my durability to be 99.83 because reasons. And
is
then you can
it
tune
at that level,
quite-
or is it just number of devices lost or a number of segments lost that you set it up for? Do you say it's 99.9983 or?
No. You literally can say 510.
So I want
Yeah.
5 potential loss of 5 data set segments.
Or you could go the other way around and say 5. Yes.
So the question is, you can dial in the appropriate level of protection by the content. Now, what that means is that's the number of simultaneous losses. So let me take an easier one of 4-2. That means you can lose 4 disk drives throughout the system simultaneously and still have 100% availability of that.
4-2, you can lose 4 disk drives?
I'm sorry,
No, you can
two
lose
disk
two.
drives. I'm
Yeah.
sorry,
The
2
parity
disk drives,
segments.
and still maintain availability of that. Now, what happens as soon as the first one is lost, as soon as the first segment is lost, the system actually begins a proactive recovery of that. So what you're saying is that I want to sustain an additional loss before that first recovery finishes.
What he's saying is exactly right. So you could have 5-5 erasure coding, and that would protect you for the loss of up to 5 drives, and that's very protected.
Okay.
Yep. Thank you.
What's the physical architecture look like? I mean, I understand that in many cases you're doing replications across to S3, for example, but
Yeah.
but if I wanted to build an environment within my own data center, is that servers connected to JBODs, servers with disk within them, taking over somebody else's array and laying this on top? How does that look?
So it's usually, racks of x86 servers filled up with, I wouldn't necessarily say JBODs, but any disks. They might also have attached JBODs that look like attached disks. And then more and more they're networked 10G, but they're very commonly still, GigE as well. They're attached to a front-end network. It's HTTP on the front end, and that's also the, protocol between the nodes. So it's a very accessible architecture. I mean, it's a very familiar architecture. It doesn't need any exotic hardware or back-end connects. I mean, this is off-the-shelf. This is software to turn off-the-shelf components into a very massive.
And how is that
You don't
software?
sell the appliances or anything like that. You can just run it.
Right, yeah.
On whatever. I can go buy Supermicro.
And how is that software loaded, though? Is it a proprietary operating system? Is it an application within an OS?
So it's usually configured so that all the servers in the system will PXE boot the image that contains the software. And then that turns all of those servers into essentially a large software appliance. So the cluster itself is a large software appliance. That's very secure. It's very easy to upgrade that way because you have a central point to upgrade. And so it scales well.
So you just update the PXE image or whatever and start
Right.
rebooting those,
Yeah.
and
Yeah,
credit curve.
and we've used essentially an embedded version of Debian as our base,
Okay.
but we've stripped out all the RAID, we've stripped out the file system. It all runs from RAM.
Okay.
So that's how we're able to get 95% of the disk capacity to be used by you.
By data.
Yeah, rather than just running on top of a native Linux file system.
Okay.
So can I just ask this for Nigel? Have you got a container implementation of that?
I'm sorry?
Have you got a,
I was thinking the same thing.
have you got a container implementation of that then?
Just for Nigel.
So I'm just saving you the effort, Nigel. You haven't done
Are
it.
you asking on the record? or
Containers
off the
are last
record?
year.
Sorry, unikernel implementation.
unikernel.
Sorry, yeah.
Thank you.
Does it run on a unikernel, right?
Thank you.